Alright everyone, welcome to part 2 of IPv6 and IPv6 routing in GNS3. Now as I mentioned in part 1, we're going to work to achieve two goals. One, I want to understand the different unicast, IPv6 unicast addresses and what their functionalities are, okay? And two, I want to work together to get connectivity between these two PCs. And to do that, we're going to take a very layered approach. Now I would like you to take a look at this config. So this config is extremely bare and it's been pre-prepared. Okay, I gave the router its host name and I've configured its respective interfaces to autoconfig its IPv6 address. This is where the no DHCP needed came from. So as you can see on Acme Edge, it'll be participating in IPv6 on Gigabit Ethernet 00 and on 01. And as you can see, I've allowed it to auto-configure itself. I've done the same thing with Acme Core 1 and Acme Core 2. So let me just apply these configurations and let's get started. Acme Edge. As you may have noticed, I've also included IPv6 unicast routing. What that does is it allows the IPv6 routing table to turn on. Okay. All right, so it looks like we're in good shape. Now there's a couple of things I think you need to make note of. Now we're dealing with IPv6, which is a completely different address class than IPv4. It's like there's two completely different levels on the router. And what I mean by that is that when you're troubleshooting, most of the commands that you would normally apply for IPv4 are replicated with IPv6. So for example, if I wanted to see the route table, the IPv4 route table of Acme Core 2, I would perform the task show IP route. Okay, but you're never going to see IPv6 addresses in the show IP route command. You will, however, see them in IPv6 route. Now, I don't have any IPv6 addresses to populate to the table, and I gave you a little bit of a sneak preview of what we're going to be talking about sooner rather than later. But for all intents and purposes, in concentrating on what I'd like to just get through is the commands are different for IPv4 and IPv6. They're the same, but you just have to add the IPv6 in most cases. Okay? All right, so we're in a good place. Now, for us to verify the auto IPv6 address assignment, I use the show IPv6 interface brief command. And that's what I'm going to do on all the routers. So starting from the edge, I'm going to show IPv6 interface brief. I'm just going to copy this command. Oops, has to be in, there you go. And there you go. Now, as you can see, just doing a mashup, I'm expecting Gigabit 00 and 01 to have a link local address, and they do. Core 1, I'm expecting 01 to be given a link local address, and I'm expecting 00, which is the interface facing the PC, and 02, which is participating in subnet 2. So perfect. The auto configuration has worked. Now there is one thing I'd like to mention. As you can see, only the link local address was auto-assigned, not the global unicast or the unique local unicast address, which means that this auto DHCP mechanism only applies to the link local IPv6 unicast address, not the others. You're still going to need a DHCP version 6, okay, to be able to assign routable IPv6 addresses. So in that aspect, nothing changes with regards to the similarities of IPv4. Generally speaking, in IPv4, this PC, once it actually connects to a switch or a router, attempts to obtain a routable IP address, whether it be public or private. Usually in an enterprise environment, it would be a private IP address space, which automatically is routable. And under this circumstance with IPv6, that is not the case. The auto configuration only assigns a link local address. Now, another thing that I think is very important to mention is that in companionship to the show IPv6 interface brief command, I'm going to launch the show interface gigabit 00 hardware command, and I'm going to do the same thing with 01. And the reason why I'm doing that is because I want you to take a look at the MAC address. Now the MAC address is a 48-bit address space. Okay, now why is this important? Well, the way the auto DHCP mechanism works with IPv6 with respect to the link local address is that it takes the MAC address and basically places it or inserts it into the host portion of the IPv6 address. So if we do a matchup here, interface gigabit 00, interface gigabit 00, you can see that it goes F6, 13, FFFE, and this portion here is the EU64 rule that essentially places a padding to fill in the remaining 16 bits of the MAC address that don't exist. Because remember, the MAC address is 48 bits, the host portion of the IPv6 address space is 64 bits, so to fill that gap, it places the FFFE right smack in the middle of the MAC address value. So as you can see, this interface matches up, and so does this with the MAC address. I'd like to do the same thing with core 1, which would be, oops, didn't like that. Perfect, it's identical. Let's do the same thing with 02. Yes, and 00. Perfect, they look identical. And it has inserted the FFFE right smack in the middle of the 48-bit MAC address space. Now, there is one thing that I'd also like to mention to you, and we're going to verify this as a test. Now, I've always said, and even in the previous sections, I've said that the link local address, unicast address space is not routable, right? However, if you notice, the core 2 gigabit 00 interface pertains to the same subnet ID as 02. So does that mean that PC1 can actually ping IPv6 link local addresses if it pertains to the same subnet? I mean, it looks like this subnet, subnet 2 and subnet 3 are identical. If I go to Acme Edge, and I take a look at the same thing, you can see that interface 00 and interface 01 pertain to the same subnet ID. So we're going to go through this test very soon. All right, so let's begin our testing. Let's just see if PC1 can actually ping the interface of Acme Edge. But before that, I want to try, and I want to see if Acme Core 2 gigabit 02 can actually ping this interface and also ping that interface. Because at the end of the day, this is considered one link, the subnet, the broadcast domain. So let's take a look. So to do that, all right, I got to go back here, and I got to do a show. I actually have the command right here. So this is 01. So this is the IP address of 01 on Acme Edge. I'm going to copy that. I'm going to go to Core 2, and I'm going to ping this address. And it's going to ask me, it's a little bit different. It's going to ask me for the out-facing interface. So in this case, it's gigabit Ethernet 02. Perfect. So it worked. Let's see if Acme 2 works. So gigabit Ethernet 01. I'm going to copy this. I'm going to go to Acme 2, and I'm going to ping out the same interface, and I can reach it. So I have just proven that gigabit Ethernet 02 can actually reach gigabit Ethernet 01, and it can actually reach 01 on the Acme Edge. So it can reach both. And the fact that the ping replied means that it's also valid in the opposite direction as well. Now the question is, let's go to PC1. All right. Let's go to PC1 for a second. So with PC1, I'm going to do a show command, and by looking at that, you can see that this interface here is pertaining to the same subnet as this interface and as this interface. So the first thing I want to do is I want to try this, and then I want to try this, and we'll see if that works, okay? All right. So I'm going to go on Acme2, do my show IP version 6 interface brief. I'm going to grab interface 00. I'm going to go to PC1 and I'm going to ping this and see it works. I've gotten replies from the IP version 6 link local address on Acme2. So let's go to Acme Edge. Now I have it right here. So I'm going to take this IP address, IP version 6 address, I'm going to go to PC1, and I'm going to go ping. I'm going to paste here, and let's see what happens. I'm getting timeouts. But that's interesting because they're on the same subnet. So why is that the case? Well, let's think about that for a second. All right, I think I have the answer. So essentially what's happened here is that under traditional circumstances, if we think about IP version 4, this subnet here, all right, this IP address of this PC, to be able to reach this IP of this router, it's going to have to be routed, right? Which means that the router, Acme Core 2, has to perform some sort of logic, which means it has to consult its IP version 6 routing table. Interesting, right? So if we go to the IP version 6 routing table of Acme2, there is no route, meaning that the link local addresses are not routable because they are not eligible to be inserted into the IP version 6 routing table. This is fascinating. It's so important to comprehend. So even though the subnets are identical on this link and on this link, and I'll probably even guarantee you it's going to be on this link as well, because these IP version 6 link local addresses are never inserted in the routing table because they're not eligible to be routed, you've created segmentation. Okay? And we also have to understand the reasons why. What is one of the characteristics of the link local address? Now, the link local's main objective is to share network node information between neighbors on the same link. Okay? Its behavior is to create a private interconnection, a private connection to pass neighborship information. So on this subnet, there is a relationship between these two routers, which the link local address is isolated to perform and help achieve. There is a relationship between these three routers that the link local address helps to facilitate. But none of these link local addresses are ever inserted into the routing table because it's a private connection with the neighbors on the same subnet. Hope that helps.